Welcome to everyone. So today I am discussing the numerical problem based on lenses, and this topics is very important in CBSE examinations and other boards examinations. Especially we are focusing today the NCERT numericals. Okay, NCERT, not only NCERT, besides of that CBSE numericals is also there. So these numericals I am discussing today. So let's start. So the first numerical is what? A screen is placed 90 centimeter from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeter. Determine the focal length of the lens. So how you can solve this type of numerical problem? So try to understand here. One thing is screen is placed 90 centimeter from the object. So see, at first let us draw. So this is what? This is the screen. If I draw, and this is what? This is the object. Let the object is what? AB, right? Now if you placed a lens, so this is the lens that you have placed here, right? This is L lens. Let the object distance is U and image distance is your what? V, because image is formed on the screen. So this distance, the distance between object and the screen, it is what? Capital D, and capital D is given here 90 centimeter, right? So how you can solve this type of numerical problem? So see here, try to understand here. If I write the lens formula, general formula, the lens from the lens formula, what you can write? That is equal to 1 by V minus 1 by U is equal to 1 by F, right? So see, that is equal to 1 by V means what here? Try to understand. That is V is equal to D minus U, because U plus V is equal to capital D. Okay, so V is equal to, I can write here D minus U, minus U will be what? See, actually the rays, incident ray is this direction and you are measuring opposite to the incident ray, so U will be your negative, F is positive. So what you are getting here? That is equal to 1 by D minus U plus 1 by U is equal to 1 by F. Now if you take the LCM of these D minus U and U, so just LCM is very simple, U into D minus U. So this is equal to your U plus D minus U is equal to 1 by F, right? So this giving you what? This giving you U into D minus U, and this cancel. So this is D is equal to 1 by F. So just try to understand. Now if you take the cross multiplication, so this is equal to your DF is equal to U into D minus U. So this is giving you DF is equal to DU minus U square, right? So see, just try to understand here. Now I am writing, so just see, minus U square, if I put here left side, this is equal to plus U square, right? This is equal to your plus U square. Just a second. Yes, this is equal to your plus U square, and see this du, if you put left side, this is equal to your minus du plus df is equal to 0, right? Now if you take, so this is your quadratic equation. So u square minus du plus df is equal to 0. So if you want to solve these equations, so that is equal to what? That is equal to, you are getting here what? That is equal to u is equal to what? This is the quadratic equation. So Sridharacharya rule you can apply. So this is equal to minus b plus minus root under b square minus 4ac divided by 2a, right? This way you have to solve. So here b means what? minus d. So this becomes what? B means what here? Minus d. So this becomes plus d plus minus root under b square means minus d square. 4 a means here 1 into c is equal to your df divided by 2. So you have got this way. So so see, you have got from here two values of u. One is u1, that is equal to d plus root under d square minus 4 df by 2, and another one is what? u2. u2 is equal to, you have got d minus root under, see, d minus root under d square minus 4 df by 2. Okay, so see, if you try to understand, if you have got these two values, this is, I am putting here equation number 1, this is I am putting as equation number 2. So from 1 and 2, okay, what you are getting, that two values of object distance you have got, the image is formed on the screen, right? So that means what? That means, see, here I am drawing. So this is, just see, this is the object AB and this is the screen. Okay, this is the screen. And see, so at this position, suppose this is the L1 position of the lens L. So here the object distance is your U1. Okay, here you have got one image. Okay, here you have got one image. Same way, if you consider the, if you consider this one, okay, so see, just see here. So that means, suppose if you consider this one, so see, AB is the object, screen distance is your d. So next one is what? Next one is your, this is the L2 position of the lens. So here this distance is your U2 and this distance is giving you V2, right? So two distances of object U1 and U2, you have got two images on the screen. So that means here from the question, what is given? From the question it is given that U1 minus U2 is equal to x. So see, this is the L1 position and this is the L2 position, and their separation is your x, and this x is here 20 centimeter, right? So if I just try to understand now, if I calculate here that x is equal to 20 centimeter, and x means what? X is equal to u1 minus u2. Okay, this is equal to your x. So see, u1 is equal to what? u1 is equal to your d plus root under, so here I am writing u1 is equal to, just I am substituting the value of u1 and u2. So see, that is equal to, u1 is equal to your d plus root under d square minus 4 df divided by 2. This is the value of u1. Okay, and u2 value is equal to what? u2 value is equal to d minus 4 d, see, d minus root under d square minus 4 df by 2. Okay, so see, yes, u2 value is equal to d minus root under d square. So I am substituting the value of u2, that is d minus root under d square minus 4 df by 2 is equal to x. Okay, so if you can understood this one, so that is equal to what? So 2 is your LCM, so this is equal to d plus root under d square minus 4 df minus, this is equal to d minus minus plus root under d square minus 4 df, right? Just this is equal to x. So that is equal to, so d and d is cancelling. Okay, so now you have got which things? You have got root under, see, d square minus 4df, and this is also plus d square minus 4df. So you have got only d square minus 4df 2 into this one divided by 2, that is equal to x. So see, d square minus 4df is equal to x root under. So both side if you square, so this giving you d square minus 4df is equal to x square. So that means equal to what? 4df is equal to d square minus x square. So f is equal to d square minus x square by 4d. This is very important formula if you are provided that screen and object distance is fixed, but you are moving the lenses, right? And two position of the lenses, just try to understand that two position of the lenses, image is formed on the screen, then focal length of the lens is giving you d square minus x square by 4d. So that is equal to what? So from these questions, so d is what? D is equal to 90 centimeter. So I am writing here. So d is equal to, just see, from here d is equal to 90 centimeter, x is equal to 20 centimeter, right? So now focal length will be what? 90 square minus 20 square divided by 4 into 90. Okay, so if you calculate this one, just try to understand. So this will be your what? 90 plus 20, that is equal to 110, and 90 minus 20, this is equal to 70, right? So 4 into 90. So if you calculate this one, so this and this one is cancelling, so this is equal to 7. Okay, this is giving you 770 by 4 into 9, 36. Okay, so after calculating, you have got which things? So that is equal to, you have got here 221.4 centimeter. Okay, this is your answer. Okay, so this is your first questions, and now next we are considering the second questions of it. So let's start with the second questions. So see, so your second questions is your, okay, just see, your second question is this one. Okay, okay, just see, at first I am, just see here, this one is your second question. Okay, so see if you can understood this one. So previous question, so this is very easy question. The image of a small electric bulb fixed on the wall of a room is to be obtained on the opposite wall 3 meter away by means, okay, by a large convex lens. What is the maximum possible focal length? So see, the same type of question is given, that image of the small electric bulb. So if you consider this is the bulb, okay, and fixed on the wall, so this is the wall, okay, this is the wall, here the image is formed by a convex lens. So okay, opposite wall 3 meter away, so that means equal to, from here to here, this is 3 meter, this is giving you your capital D, right? So here the question is opposite 3 meter away by means by large convex lens, what is the maximum possible focal length? So see, the focal length formula is what is the focal length formula? Just recently we have find out d square minus x square by 4d. So I am writing here that d square minus x square by 4d. Now this is the focal length formula. Now next one is what? Where the x is the distance between the two position of the lenses, right? So this is, suppose for example this is the first position, this is the second position, so these two position of the lenses distance is what? X. Now maximum possible focal length, try to understand, if try to understand x has any value, then focal length will be decreases, right? Focal length will be decreases. So for maximum focal length, that will be what? So for maximum, here I am writing for maximum focal length, okay, x must be equal to your 0, right? So if x is equal to 0, then you are getting this focal length is equal to your maximum focal length, and maximum focal length is equal to what? That is equal to d square minus 4d, that is equal to what? D by 4. So that is equal to, if maximum value is equal to your d is equal to giving you 3 meter by 4, okay. So that is equal to 0.75 meter, 0.75 meter. So this is your answer. So this is your maximum possible focal length, okay. This way you can solve, right? So next, see the next problem. So see, next problem is your what? This is very easy numerical. This is very easy numerical. That is what? What is the focal length of a combination of convex lens of focal length 30 centimeter and concave lens of focal length 20 centimeter? So try to understand. So one is the convex lens and another one is your concave lens. So see, if you draw the diagram, that is equal to, so see here, this is the convex lens, I am considering this is L1, another one is your concave lens, right? This is the L2 lens. So focal length of the convex lens is giving what? 30 centimeters. So I am writing here 30 centimeter, and focal length of the concave lens, that is equal to 20 centimeter, but this 20 is equal to minus, because for the concave lens, right? So this is given. Now next one is what? Is it converging and diverging? Ignore the thickness of the lenses. So try to answer. So combination of focal length. So which formula here I will use? So see, the formula will be your what? That is equal to, here I am writing, that is equal to 1 by f is equal to 1 by, for the combination of the focal length, 1 by f1 plus 1 by f2. So this is the formula. So that is equal to what? That is equal to 1 by f is equal to f1 f2 is your LCM. So this is equal to f2 plus f1, right? So focal length of the lens will be your capital F will be your what? F1 into f2 divided by f1 plus f2. So that is equal to, f1 value is equal to what? 30, f2 is equal to minus 20, okay. So here I am writing minus 20 divided by f1 is equal to again 30 plus f2 is equal to minus 20, right? So this is giving you what? F is equal to, this is equal to minus 30 into, that is equal to 600, right? Directly here I am writing 600 divided by 10, okay. So this is giving you minus 60 centimeter. So this minus is signify what? This will be what? Converging or diverging? Your answer will be what? This is your diverging lens, right? So this is your diverging lens, because minus signifies that what? The nature will be your concave nature, right? So this is your diverging lens, okay. So this way, right? So okay, now if you can understood this one, so now next problem is your what? So let's talk about the next problem. So see, this is your next problem, that is equal to, just see the next problem. So see, this is a beam of light converges at a point P. Now a lens is placed in the path of the convergent beam 12 centimeter from P. At what point does the beam converge if the lens is, first one, convex lens of focal length 20 centimeter, number 2. So first I am, just see, first things here I am doing. So see, question is giving that what? A beam of light converges at point P. So see, so this is the convergent beam. Let I am considering this is the convergent beam, right? So try to understand this convergent beam is, see here, so they are meeting at how much? So suppose they are meeting at this P prime point, right, this convergent beam, okay. But just try to understand at point P. Now a lens is placed in the path of the convergent beam 12 centimeter from it. So from this try to understand, so sorry, here P is the point. So see, from this P point, if you keep a lens, suppose in the first case, so first question I am answering, so this is first question. So suppose if you keep here convex lens L1 from 12 centimeter from this P point, right. So see a convex lens of focal length 20 centimeters. So see this focal length is also giving 20 centimeter, right. So see here you have to find out what at what point does the beam converge. Now see, try to understand. So here what I am writing, 1 by, just see for the first question, 1 by V minus 1 by U is equal to 1 by F, right. F1 I am writing, and this is V1, this is E1. So see, try to understand, this is very important things. If the lens is not placed here, so the convergent ray will meet at this P point, right. But due to this convex lens, the ray is, suppose after refraction through the lens, suppose the rays are meeting at this P1 point, right. So you have to find out this P1 distance from the lens. This is V1, okay. So this is your V1, right. So V1 you have to find out. Now U1 is what? This is your U1. Which one is your U1? This P to the optical center of the lens, this distance is your U1. Why? Because this is, just try to understand, if lens is not placed here, suppose lens is not kept here, then this convergent beam were meet at which point? P point. So this P point is acting as the virtual object for this convex lens, okay. So this U1 is your object distance, but and see here this object distance is your positive because incident ray is this direction, object you are measuring along the incident ray. So in this situation I can write here, so that is equal to, here I am writing 1 by V1 we have to find out minus 1 by U1, U is positive, focal length is also positive, this is equal to your 20 centimeter, 1 by 20. So suppose if you calculate the value, so 1 by V1 is equal to your 1 by 20 plus 1 by 12, right. So the value of here 1 by V1, so this is giving you what? This is giving you, its LCM is equal to 60, right. This is equal to 60, and its LCM 1 by 20 and 1 by 12, this LCM is equal to your 60, and this is your 3 plus this is giving you 5, so that means your 8 by 60. So V1 value is equal to your 60 by 8. So suppose if I consider this one, this is equal to 4, 2, this is equal to your 15. So V1 value is equal to 7.5 centimeters. So this value is equal to your 7.5 centimeter from the optical center, right. This is positive, that means along this incident ray, right. So now coming for the second part. Second part is what? Same, but here you have kept a concave lens. So see, if I consider the same things, just try to understand. So see, this is the convergent, right. So they will meet at which point? P point. Now here if you keep a concave lens, right. Now what will be happening? Just try to understand. So see here, then same type of concept, this is your U2, U2 is equal to your 12 centimeter, right, 12 centimeter. So see, if this is the 12 centimeter, next after that it will what, it will refract, I mean just try to understand. So it will after refraction through the lens, suppose it will meet at v2 distance from where, from the lens, right, v2 distance from the lens. So if I apply the formula, lens formula, that is equal to 1 by v2 minus 1 by u2 is equal to 1 by f2. But try to understand here, this f2 is equal to given 16 centimeter, but this f2 is equal to your negative, because this is the concave lens. So that means equal to what, that is equal to 1 by v2. We have to find out 1 by v2 minus u2. u2 is, this is positive, 1 by 12, and f2 is equal to your minus 16. So that is equal to 1 by v2 is equal to minus 1 by 16 plus 1 by 12. So this will be what, this is giving you, the LCM will be your 48, right, 48. So this is equal to your 3, this is 4. So that means equal to 1 by 48, 1 by v2 means, so v2 is equal to your what, so the value of v2 is giving you, just try to understand, the value of v2 is equal to your plus 48 centimeters. So from here this ray will meet at 48 centimeter from the lens. Okay, so this is your problems. Okay, thank you.